of dispersion or variation. The objective of the video is to introduce to you the different measures of variation or dispersion, how these measurements are defined, and in what ways do we compute these measurements. So let's start with the first, with this scenario right here. Notice the context of the example here is that we're going to compare two brands of paint, the longevity of these paints. We have brand A and brand B, and each brand will use 6 samples. So usually when we're asked to compare, our immediate response to these types of question is to compute for the mean. So should we compute for the mean, we are going to have the following mean for the two. And notice, both have the same mean, which is 35. It's not possible to create a comparison using mean here because this comparison is not correct. Mean cannot be used to compare the two brands. However, we may compare it if we use a different type of average. We could have median or mode, for instance, but we cannot really tell something about these bands. It's also quite different to compare. Sometimes it's only applicable, I mean, for me, it's best to use median and mode if we only have one distribution. We only want to make interpretations to one distribution or set of data. However, we have two sets of data here, and we would like to see that there is a difference between the two. In that case, we might be helped by the range. The range is the distance between the highest and the lowest value. In other words, we are just going to simply subtract highest value and lowest value together. Just get the difference of those numbers. So we go back to the example earlier, and this time the samples are presented in a number line just to see you the distances of these numbers. Because the idea behind measures of variation is that we'd like to see how far each data set from each other, or if we have a mean, how far are these data sets from the mean. And we can also see the relative distances as well between the numbers in the first band and the numbers in the second band. And notice how they're gathered around the mean and how dispersed these values are. So band A is more dispersed and band B is less dispersed. They're quite compact. Now, can we make interpretations? Of course. In terms of longevity, which do you think is a more which has more longevity here? So let's compute for range of brand A first. So 60 minus 10, the answer is 50. And then for brand B, 45 minus 25 is equal to 20. So what does it mean? We may simply say that brand A is greater than brand B in terms of range. And this range should also reflect to which brand of paint lasts longer. In this case, our brand of paint that lasted longer is brand B, brand A. Brand B now, the longest that it lasted is 45 months, while the longest for brand A is 16 months. And in comparison to the months where the shortest, although brand A has the shortest, majority of the ranges of the values in brand A are quite far, meaning it's too dispersed. Mas malalayo. Let's see another example right here. So notice, ating given dito, owner, who is earning $100,000. I don't know if it's a month, I think it's yearly, is too far from the rest. So in other words, if we are to reflect this one as an as in a distribution, this is already an outlier. And remember, we don't use mean if we are going to if we have outliers in our distribution because imagine having a mean here. So let's try to interpret this one using mean first. So suppose we are going to compute for the mean of this distribution. We will just try and see ano bang pinagkaiba kung gamitan natin to siya ng mean. So I added everything here and it resulted to 228,000. And this 228,000 will be divided by the data set 1, 2, 3, 4, 5, 6. So there are 6 right here. So assuming we have a mean of divided by 6, 38,000. So how do we reflect this one? It doesn't really make sense if we are going to make a number line here. Because if this is our number line, and suppose we have here 38,000, notice, majority of the numbers are gathered in this region right here. And 100 is over here. It's too far. And it's quite difficult to make interpretations when your data sets are this far, when you have an outlier. Hence, if we would like to use a different measure of central tendency, we could have used median or mode, for instance. Mode cannot be, so median probably. And if we are to arrange this one according to median, then we would still get values between around 30-ish something, which is still not, we cannot still make any interpretations. Wala pa rin something to interpret using those averages. So it would be better if we have range instead. So what happens if we have range here? So if we are going to use range, we are just going to simply subtract 115,000. So we have 85,000 as the difference. So we can say that the difference between the owner and the workers with the least salary is 85,000. And that in itself is already an interpretation of this. So when you would like to see how distant are the numbers from each other's, measures of variation is good. For instance, for this example, we have a range here where it can show the distance between the lowest value and the highest value. So paulit-ulit din talaga yung meaning na ating range. Now let's proceed to another type of measures of variation or dispersion. We call it the variance. So it's to measure how far a set of data is spread out. In Filipino, gaano ba kalalayo yung ating data set? Are they close to each other or are they very far from each other? But when we talk about variance, we have to ensure that we have computed our mean. And since we will use mean in our calculations, and mean would not entertain any outliers or extreme values in our data set, then we have to remember that we can only use variance and later on the square root of variance, which is standard deviation, only when we don't have extreme values or outliers. If we do have, then we just go back to range. But since we're talking about variance now, variance of 0, meaning there's no distance at all. They are identical in terms of distribution. Their place in the number line is identical, meaning they share the same area. So there's no distance really to compute. And ideally, if you would like to have very close data sets, we would like to have small variances. And if you would like to have very distant values, then we would like to have high variance distribution. Standard deviation is this will certainly show you how far dispersed, spread, or scattered the values are when you present them in a graph. So Usually, you don't use variance anymore. What you will compute more likely is the standard deviation. But variance and standard deviation are just related because standard deviation is taken from the square root of the variance. For instance, we'll have the same, we will look into this graph first before we will have our example. So, tingnan natin itong graph. Again, variance is using mean, hence we would assume that our data are normally distributed. So we are going to use the normal distribution, yung ating bell curve. And since yung mean is nakikita sa gitna, the idea of variance here now, or the standard deviation, is to tell us how far the other values are from the mean. And to tell us how far they are from the mean is our standard deviation. So suppose dito yung ating mean, gaano ba kung wari, dito yung score banda dito sa nilalagyan ko niya. No? Kunwari, nandito banda yung values or score, gaano ba kalayo itong score na to dito sa mean? The answer to that is the standard deviation. So it will tell us how far, how dispersed the deficits are. Example, pwedeng dot lang ako dito. This will show very small variance in standard deviation. This distribution is less dispersed. However, if you see this type of distribution, this is very dispersed, meaning the values are not that close. It's sa Bisaya pa to, katag siya. So, masyadong lalayo yung mga data sets natin. Next, let's see what the formula of variance and standard deviation is. The formula in the upper part is for the population variance, while the lower part is our sample variance. Now, sample standard deviation. The S squared is what we represent for sample standard deviation. Usually, we use sample standard deviation when we have 30 or lower n values. And this one is when we have greater than 30. So these are the formula. To internalize this better, we will have examples. Assume that this is our distribution and you are to get the population variance and standard deviation. So we have 6 values here. Let's compute for the mean first. So the mean here is 35. Again, add everything divided by the numbers. The total number of values, we have 6, and 210 divided by 6 is 35. Once we get our mean, which is 35, we arrange the values into columns. So we have column X here with all these numbers, and we have column X minus mu, meaning we go back to the formula where we have X minus mu inside the parentheses. Just a little bit. So what we're looking for now is this value right here. Yung nasa loob ng parentheses dun sa ating formula. So how do you get this? You subtract X value by the mean na 35. So ito yung ating mean dito. Nakasubtract siya sa ating X values here. And these are the results. Is it possible to have a negative value? Of course. Because sometimes each value may be smaller than the mean. So once you've obtained this, ang answer dire is square natin, meaning multiply by itself. So 0 times 0, 10 times 10, negative 5 times negative 5, 0 times 0, 5 times 5, and negative 10 times negative 10. And these are the results. Now what do you do next? You add all the values under here, which is 250, and then n is equal to 6. So we substitute it to our formula. Remember, this is the formula for the standard deviation, variance first, sorry. So sigma squared for variance. So we substitute x minus mu squared. So instead of thinking in some number, we can use this instead. 250. That's the beauty when we are going to create tables first before we proceed to the formula, so that you understand where you're getting these numbers from. So n is equal to 6. Since we have 6 here, we put the 6 here. And then you compute it, and then 41.7. Now, if there are other decimal values here, if you're going to get the result of 250 divided by 6, if you find another value for that, you may extend your decimal values again to 4 decimal places, but this one will be fine if you only ask for variance. Now, if you're asked for the standard deviation, for the sake of example, I'm just using 41.7 here, but it would have been nicer if I could use more decimal places in the values here, because just like in mean, we would also like to insist on using more decimal values if it's not yet the final answer. In this case, we are going to assume that standard deviation ang ating final answer. So square root of 41.7 would be 6.50 in the calculation. So that would be it. So ang distance ng mga numbers na to, kung i-graph natin to siya, is that from the mean, the result is 6.50. Next. We may compute for sample variance and standard deviation using a shorter formula. In other words, we still are going to create our tables right here, but instead of subtracting, we don't need to. We will just simply get the square of these numbers and then solve it without really having to proceed to subtraction pa muna, tapos magsa-square ka na naman ulit. You don't have to subject yourself to that process. So, for instance, ito yung ating given, di ba? So, mas madali, square mo lang siya agad. And these are the results when you're going to square it. Yung isa kasi kanina, may table ka for x, and then isubtract mo na siya, tapos yung mga results ng subtractions, you square those. But that's not necessary here. You will just automatically square the numbers and then substitute them in the formula after you have acquired the sum of the x column, which is 210, and the sum of the x squared column, which is 7,600. So once you have these, you go back to the formula. This is the formula. Substitute it. N is 6. And we have summation of x squared, that is 7,600. Summation of x, which is 210, and square natin siya. So make sure you put this inside the parenthesis. And then substitute yung dalawang n dito ng 6. And once you have done that, this should be your variance now, which is 50. And you square 50. You put the 50 inside the square root, and you've had 7.07 standard deviation. So, ito yung ating distance now. In using standard deviation as your basis in calculation, suppose you're going to compare two standard deviations. If your aim is that there is not much of a difference among values, then prefer the smaller standard deviation. Pero kung gusto mo na mas malalayo yung distances ng mga values, mas ipiprefer mo yung may malalaking standard deviation. Kasi ang meaning ng the higher the standard deviation is, the more dispersed the values or spread the values. And the lower the standard deviation as well, the closer the values are in the distribution. Suppose we have the example. Now you're going to look for range, sample, variance, and standard deviation of the following data set. Now remember, I said earlier that range is ideally good for distribution with outliers. It doesn't mean that it's good for outliers, and you cannot use it strictly when there is no outliers. Range can be used anytime, but if you are going to use range, sample, variance, and standard deviation, tapos yung given natin is my outlier, you'd rather choose range than sample, variance, and standard deviation, because the reason behind is that sample, variance, and standard deviation is using mean, and mean is affected by outliers. So the safest option is the range. But in this case, there is no outliers or extreme values in the distribution, so we can automatically compute that. Range is equal to 3.1, sample variance is 1.276, and sample standard deviation would be 1.13. Again, those are your choices if you would wish to compute for the standard deviation of these. I mean, if you are asked options, which is better, is it range, sample, or standard deviation, it would still depend on whether the samples have outliers or none. It's still related to the previous topic, which is the measures of variation. Hope you understood something. Thank you.